Good evening, everyone. Okay, let's start. I hope you can see the screen. We have solved this A of example 10, right? Now we are going to B, right? I did give you these two questions for homework, right? I hope you have finished those, right? All right. So let's solve the part B of this one. Remember, in exam they're not going to give you this diagram. So this diagram is in the solution. So you cannot use it. Remember that. Okay. We have to learn how to do it without that diagram. Let's start. So I'm going to read the question first of all. So it says that a 900 pf capacitor is charged by 100-volt battery. How much electrostatic energy is stored? Okay, that's done. The capacitor is disconnected from the battery and connected to another 900 pf capacitor. Now see, this another capacitor is actually uncharged, right? It's not given, but typically in such situations it is understood that the other capacitor is uncharged. All right. What is the electrostatic energy stored by the system? So if that happens, what is the electrostatic energy stored by the system? So let's start. So first of all, do we have Kevin in our class? Who's Kevin? Okay. So I'm saying that first of all, there is one capacitor, right? C. It has been charged. Let's call it C1 actually, right? It was connected to battery and it was charged, right? Then we disconnected the battery. So the second step was we remove the battery. We don't touch the capacitor, all right? We let it be like that. We remove this capacitor, and then we bring another capacitor, right? Let's say C2, okay? And then we join them. We connect them like this, right? We connect them like this. So this is given, right? The first capacitor was charged with a battery, right? Then we disconnect the battery, we bring this second capacitor, and then we connect both. All right. Now, so the question is, what is the final energy of this system? Of course, you can always write this as U1 plus U2, correct? U1 plus U2, that is energy stored in capacitor 1 plus capacitor 2. That is capacitor 2, right? So whatever that is, we'll find it and we'll get our answer. But for finding any of these, for finding U1 and U2, you need to know what's the charge stored, you need to know what's the potential difference or something, right? So what we'll do is we'll try to find the charge stored and all that. Let's begin. Okay, so if you try let charge on capacitor 1 is C1 before connecting it to the other capacitor is or be Q. ના નહીં રે એટલે તો તકલીફ છે. You will see. Right? So before we connect this with the other one, this had a charge Q. So plus Q on this plate, minus Q on that plate. All right. Now if you are going to connect it like this, what happens is that the charge will be redistributed. Right? Let me repeat. When you connect it like this, the charge will be redistributed. The reason for that is, in short, the reason for that is that this point or this plate is at higher potential and this plate is at lower potential. So what will happen is that because this was not charged, this is uncharged, right? So what happens is when you connect these two, from this higher potential point, some charge will start flowing towards the this point, okay? And this second capacitor will also get charged. And similarly, when you connect this, same thing will happen here, right? So what happens is that the first capacitor behaves a little bit like a battery, right? This capacitor will behave a little bit like a battery and it will charge the other capacitor. All right, okay, but that process cannot continue indefinitely. It has to stop somewhere, right? So what happens, that's what we are going to study, right? So you could write, after connecting the capacitors, let charge on charge stored, okay, charge stored by capacitors be Q1 and Q2 respectively. Okay, you can use any symbols as you like. It's not really about symbols. So what I'm saying is, after we join this and after everything settles in equilibrium, let's say this has a charge Q1 and this has a charge Q2. Now, if I say that this has a charge Q1, what this typically means is that this plate, this left plate has a charge plus Q1, the right plate has a charge minus Q1, this left plate has a charge plus Q2, this has a charge minus Q2. Is this clear? Okay. So now what's going to happen? Have a look at this. I'm writing a step that you don't need to put, okay? This is just for your information, right? Okay, this step is just for your information. It is as two, as two plates, as two left plates make isolated system. Have a look at this. Have a look at this diagram. Look at the left plate. If I would take a system like this, see, it's not touching anywhere, right? What we are doing is, by using some kind of insulating handle, we simply join this with this, right? Okay, it's not touching anywhere else. So even in this situation, right, if you look at what's the total charge on the left side of the system, or I mean the left part, okay, you're going to see that the total charge on the left plates together is Q1 plus Q2, that is final. This final charge should be equal to the initial charge. Agreed? This is law of conservation of charge. Is this clear? This is by law of conservation of charge. Clear or not clear? Can you please say yes or no? This is actually the most important step in this question, right? બાકી તો બધું મેથ્સ જેવું જ છે, એમાં કઈ છે નહીં બીજું. All right. Okay. Now, so this is a common thing that you will have in all such questions. What's this zero for? Can you tell me? What is this zero for? Look at the diagram. Can you tell me what is that zero for? Okay. Yes, Kia, that's right. Very good, Susti. Very good. Correct. Okay. So that would mean, yes, that would mean you have understood this, that this zero is for the second capacitor which was uncharged, right? That's why you are getting that zero over there. Okay, very good. Now, so let's continue with the next step. It is that now if you look at these two capacitors, right? I think you understand that if I take 1 point, okay, I'll just draw one more diagram over here, slightly bigger, so you will understand what I'm saying better, right? This is what we have, right? So if I'm going to take 1 point over here A and 1 point over here B, right? Then clearly VA is equal to VB, right? And similarly, if I take 1 point over here, 1 point here, right, then VD is equal to VE, right? Okay, VD is equal to VE. So that would mean that the voltage for these capacitors is also equal, correct? That would mean voltage is also equal, right? Also voltage across each capacitor is, you could write a V dash or anything. All right, it is equal. I hope you understand why, right? Because VA is equal to VD and VB is equal to VE. If you are going to subtract these two, you are going to get the same value, right? Okay. See, you can't say it is in parallel. I'm just going to make it very clear. These two capacitors are not in parallel. They are not in series also, right? These capacitors, they are not in series or parallel, because when there are only two things, you should not really worry about series parallel, right? Series parallel comes into picture when there are multiple things, more than two actually, right? Okay, so also the voltage is equal. So is this clear? Q is equal to CV, right? Urvendra, that's absolutely wrong. Initial potential is not same, right? Initial potential is not the same. All right. Why are there two, Avinash? Yes, on charge will flow until potential is same. That's correct, Purvendra. Right? Charges will flow until potential is same. Right? Okay. So this is what we have. Right? So now we can find V dash. Agreed? જો હું તમને એકદમ જનરલ મેથડ શીખવાડું છું, પછી આ સમનો પર્ટિક્યુલર શોર્ટકટ એ શીખવાડ. This is general method which you can use in any tough question. બરાબર? ગમે તે હોય આવડી જ જાય તમને. So this is V dash equal to Q upon C1 plus C2, right? How much is that? What's Q? Q is the initial charge. Can someone tell me what is Q? Come on. What's Q going to be? Initial charge means in this situation, right? This is initial, or this one is initial. J koi વાંધો નહીં. What's the charge Q here? Can you find it? અહીંયા જે હોય એ જ આવે. I'm sure you understand why. Find this charge Q. It's not Q by 2, Shivangi. Okay. કેમ એટલી બધી વાર લાગી? શું તકલીફ પડી? હા. We have got only 3 answers so far. No, Devan. અરે Q એટલે શું? If you are writing Q is Q by 2, એવું તો થોડું ચાલશે. People, I am asking you, when you connect this with battery and this gets charged, right? Okay. So what is that charge? What is that value of Q? Are you sure, Sakshi? 100 કેવી રીતે આવે? What is capacitance? Yes, very good. Capacitance is capacitance is 9 into 10 raised to minus 7 coulomb. Sorry, farad. Right? And battery voltage is, what's this battery voltage? What is the battery voltage? 100 volt. All right. બરાબર ને? So charge stored is C into V, that is 9 into 10 raised to minus 5 coulomb. अच्छा ओલું picofarad છે. Sorry. I'm so sorry. So this is going to be minus 10. મારું ધ્યાન ક્યાંક બીજે. So this is going to be minus 8. All right, 9 into 10 raised to minus 8 coulomb. Yeah, 100. 100 volt. Okay. So finally, we're going to put this value here. Nine into 10 raised to minus 8 divided by C1 plus C2. How much is C1? How much is C2? Both are same, right? It is equal to 900 PF. So 900 into 10 raised to minus 12. So this is going to be 100 volt. All right. Oh, sorry. Into 2 to કરવાનું રહી ગયું. So this is going to be 50 volt. Clear? Okay. So V dash is equal to 50 volt. Right? So what's the energy stored? બસ પતી ગયો હશે હવે. We have had so many distractions. There were at least 3 attempts to enter our meeting by unknown persons. Right? It's like now someone named Champak is trying to enter our meeting. Sutras here. Avinash, is that you? So energy stored in system is U equal to U1 plus U2, right? So half C1 V dash square, right? Because now the voltage of the capacitor is, then I'm going to remove you, Avinash. Is that fine? Okay, fine, no problem, Avinash. So let's continue. I was saying that the energy stored in system is U1 plus U2. So for first capacitor it is half C1 V dash square. For the second capacitor it will be half C2 V dash square, because V dash is same for both, right? Okay. So now this is going to be 1 by 2 V dash square common. Even C1 and C2 are equal, isn't it? So we can just say that this is 2 times. Is that okay? All right. Clear? Go through this whole thing, then I'll tell you the shortcut. See if you have some question, everyone. પહેલા આનો answer find કરજો, પછી બીજું બધું. Find the answer, then go through the whole method. See if you want to ask something. Hmm, 225 ke 2.25 something else, right? Any questions of any kind? 225 microjoule આવે કે 2.25 microjoule આવે? Okay. Right? I believe you have understood this. Okay, so that's all you have to do really. 9 into sorry, this 225, and then the rest are all zeros, correct? So that's going to be 10 raised to minus 4, એટલે 8 થઈ જાય, બરાબર? 2.25 microjoule it is, right? Now see what are the, okay, no problem, Avinash. So I was just saying that this method, right, is the general method, right? Even if two capacitors are different, right, or anything, any such situation, this method would work, right? So let's very quickly go through what are the key points here, right? And then based on that, I'll tell you the shortcut. See, is that first of all only one capacitor was charged, so charge on this was Q and charge on this was 0, right? So in fact you could write this Q as C into V, isn't it? Right? You could write this as C1 into V or C into V as you want. Then when we connect these two, this charge gets distributed, right? So this will also get some charge, that will get some charge. But the main thing is that because it's an isolated system, the total should be same, right? The total should be same. So that brings us to this important step, right? Okay, the first important step is this, right? Then based on that, we can, just look at this diagram. You can say that the voltages are equal, so that's step 2, that the voltages are equal, right? So if we use step 1 in that step 2, so we get this relation, and then we solved it, right? So we could find everything. Clear? Right? Okay. And then we found energy. So that's the final step, actually. Now, if you want to do all of this in short, in this particular question, then you can always say that, well, we have C and we have another C. Both are identical, isn't it? That is, their capacitance is equal. If capacitance is equal, then they will distribute half of the charge each, because both are identical. Is that okay? So because they are identical, you could say that charge on each capacitor is q by 2 and q by 2, or charge on both capacitor is q by 2 finally. Is that okay? Right? So this is actually a very easy way. હા કહું છું પૂર્વેન્દ્ર, બાકીની એનર્જી ક્યાં ગઈ સમજાવો. Okay, so charge on each capacitor is q by 2. So if you do it that way, it becomes very easy, right? Okay, in fact, you can do it so easily like this. U is proportional to q square, correct? તો u1 જે છે ને એ ઓરિજિનલ જે આપણે આવી હતી ને એના કરતા કેટલી આવશે 1/4. પહેલા કેટલો આન્સર આવ્યો હતો? પાર્ટ A નો આન્સર. What's the answer of part A? What's the answer of part A? Nobody is telling me, so all right, it was 4.5 microjoule, correct? Okay, so it was 4.5 microjoule, but this one will be divided by 4 because charge is half. So same is u2. So total કેટલું થયું? Total કેટલું થયું? U is equal to u1 plus u2 means 2u1. તો પતી ગયો, આવી ગયો આન્સર. લો બોલો, આનાથી શોર્ટ કઈ હોઈ શકે? રાઈટ? Okay, I hope you have understood this shortcut. Again, this shortcut works only because the capacitors, only because the capacitors are identical. Suppose હમણાં એવું કીધું હોત કે આ 900 pf અને આ 1800 pf, તો આવું ન થાય. તો પછી કમ્પલસરી ઓલી મેથડ જ કરવી પડે, રાઈટ? ઓકે, so even in that case, it's just this. See, step 1, you could write q1 plus q2 is equal to total charge, right? Total charge એટલે q plus 0 કે q1 plus q2, whatever, most general case, right? This is final, this is initial, એવું કંઈ. Step 2, common voltage, અને તરત જ આન્સર આવી જાય. What is common voltage? V dash. It is equal to, you can check this, you can check what I'm writing. It will be true only, right? આવું ક્યાં આવ્યું? આવું ક્યાં આવ્યું? અહીંયા. Look at this line. Right? That is what will always happen, right? કારણ કે આના steps જ એવી રીતના હોય, that you will always get total charge upon total capacitance, right? What I mean to say is you will get total charge upon total capacitance, right? ઓકે, તો આ શોર્ટકટ આ સીધું તમે કરી નાખો હોય તો વાંધો નહીં, અડધો માર્ક કદાચ કાપી લેશે એક્ઝામમાં આવું કરો તો, right? But like this you can find common voltage. Once you find common voltage, then you can find anything that you want. If you want to find q1, you can do that. If you want to find u1, you can do that. Okay, you can find all of it, right? I hope this method is clear. Okay, now Purvendra has asked me one question. He's saying that initially the energy was 4.5 microjoule, and now when we connect the second capacitor, finally the energy becomes what? 2.25 microjoule, right? So this is at start, all right, and this is what we get finally after we connect both capacitors, right? So the question is, where did the rest of the energy get lost, right? Where is the loss? Okay, where did it occur? Loss તો બરોબર value આટલી છે, but why is there a loss? Okay, so the answer is that, see, think about it very carefully. When you take this capacitor and you join it with another, in reality it will flow through, the charges will flow through the wire, correct? Charges will flow through the wire, agreed? And I'm sure you do understand that every wire has resistance, and I'm sure you remember that you have studied something called Joule's heating, right? No, not kinetic energy. Charges ultimately they come to rest on the plate, so it's not about kinetic energy. Yes, I square RT, right? I hope you all remember. I hope you remember that when a current will pass, there will be a heat, right? That will be I square RT. So obviously when charge will flow, for some time there will be a loss of heat. Okay, and that is where it will get lost. All right. Okay, fine. So that's where the energy goes, right? In fact, what if we connect directly to sphere without it? Suppose you don't connect wire. All right. Avinash is asking, what if you don't connect wire, but you have to connect it somehow, right? You have to connect it somehow, right? So obviously, even if you connect by a conductor, however good a conductor, it will definitely have some resistance. એટલે waste તો થાય ને થાય જ, તમારે ગમે તે કરવું એ કરો, right? It is impossible that there is zero resistance. Okay, so in any such situation, when you will connect a capacitor with another one, right, when charges will get redistributed, there will definitely be a loss like this. All right, there will definitely be some resistance, small but not zero. That's what you should understand. Resistance is small but never zero. Here. Okay, fine. So that's it about this question. All right, now I'm going to give you a question for homework, right? I'm going to give you a question for, what is the minimum resistance of a resistor? Depends on what it is made up of. Superconductor નું બનાવો તો અલગ વસ્તુ છે, right? But yes, it will be like very less, 0.0001 ohm and all that. Okay, it can be extremely small, right? But it's very costly to make such a thing. Okay, so I was telling you that we can uh, we can solve a question from exercise like this, right? Let me just see the number and then I'll tell you. Okay, Harsh, are you there? Can you please say yes or no if you're there? All right. Okay, so the question that I was talking about is 27 is homework. Question 27. All right, question 27 is homework. Now we are going to solve 26b. Okay, I'm sure you have done A part already. We are going to do 26b, right? Okay, fine, let's start. So it says that you have to consider a parallel plate capacitor. Okay, let me just draw a large diagram. We'll need it, I think. Right, let's say this is a parallel plate capacitor. All right, with some distance d between plate, and let's say the area of the plate is A, right? Okay, now it says that view this energy as stored in the electrostatic field between plates. So what it's saying is that because charges are stored here, right, that creates some electric field, right? Okay, so consider that the energy is stored in the electric field, right? Energy of this capacitor is actually stored in the electric field, or it's because of the electric field, right? That's what it is saying, right? Obtain the energy per unit volume U. That means we have to find the formula for U. Small u is called energy density, right? See, what is meaning of energy density here? Energy density U means energy per unit volume. Voltage na diya, potential energy stored per unit volume. Is that clear? Definition clear or not? Right, simple. And see, it's important. Okay, it's very easy. I think it's very easy, but it's also very important, right? There are very few things like this which are easy and yet important, right? So this is what we have to derive, right? We have to make a formula for this. Let's start. Okay, let's start. Energy stored, U is equal to 1 by 2 CV square, right? You can use any formula, no problem. With any formula, you can derive the same thing. All right, U is equal to half CV square. But the potential difference V is equal to ED in this case. I hope you remember this. Do you remember this? And this is not always true, right? Okay, we derived this specifically for uniform field, right? We derived this specifically for uniform fields. I hope you remember that. I think I should show you the derivation also once so that you don't take it to be, you know, general. It's not true many times, it's only true sometimes. Where was it? Parallel plate capacitor. Here, this is it. Have a look. Okay, not this one. The way I explained it, it was the other one. Just a minute. So sorry. Yeah, here. We use this relation. I hope you can read it. Okay, we use that relation over there, right? And based on that relation, based on this, we derived this point, right? So we got that the potential difference is V equal to ED. Now use it only for such situations, all right? Don't use it everywhere. So coming back to this point, okay, so what we are having is that V is equal to ED. So if I put it over there, right, or what do we want to get? Potential energy with volume. Okay, potential energy with volume, right? So this is going to be U is equal to 1 by 2 into C. Is this clear? Right? I'm putting this value and C's formula. बस एक ज step बाकी रह्यो. Right? What we are going to do is we will cancel the D out, and do you realize we will get it like this, right? But what is A into D? I want all of you to focus here. What is area of plate into distance between plates? Have a look at this. This area is A, and if I multiply that with this distance, then I'll get volume of this whole section, right? Correct? This will give me the volume, right? AD. So, right? So that's why I can write this as small u is equal to capital U upon volume, right? What is volume? A into D will be equal to 1 by 2 epsilon 0 E square, right? Clear? Okay. So this is the general relation which is true for all cases, actually not just a capacitor, right? This is a general relation that works every time. Okay, we don't have its derivation, I'm just telling you that. Okay, right? Energy density of electric field, any kind of electric field, all right? Energy density of any kind of electric field is always small u equal to 1 by 2 epsilon 0 E square. We can also use this kind of symbol, okay? Rho for density and E is for electric field. So this is energy density of electric field, all right? So remember this formula, okay? It's important. This one is important formula. આના બહુ ફાલતુ ક્વેશ્ચન આવે JEE માં NEET માં બધી જગ્યાએ, right? Please remember this formula. Okay, so that's it for this part B. I think હવે કઈ બીજું કરવાનું નથી. Let's read the question. Hence arrive at a relation between u and થઈ ગયું. Okay, done, right? Clear? So that's it. Please remember this formula. Again, this is valid for everything, okay? This is always true. Even if it's not a capacitor, this is always true, right? Okay. Now, I'm going to look at the exercise again. I'll see if there is some question that I can ask you to do for homework. Okay, so 2 more homework questions. Exercise 8 and 11. I'm not so sure about 8. If this is done, if it's remaining, it is homework. Otherwise, it's fine. All right. Exercise question 2.8 and 2.11 are homework. Please make sure you do it. Okay. Now, we are going to solve the exercise question number 28. Right? We have done 25, 26, 27 is homework, okay, and 28. All right. Okay, so we're going to solve 28 now. Please read the question, everybody. ટપ્પો પડે તો આ એક સ્ટેપમાં પૂરો થઈ જાય છે, right? But of course you have to write it a little bit, so we need to do some steps. Okay, so it says show that, means prove that force on each plate of a parallel plate capacitor has a magnitude equal to 1 by 2 QE, where Q is the charge on capacitor and E is the magnitude of electric field. All right. So what are they saying? is that suppose these are the plates, right? Okay, suppose that these are the plates, right? And if electric field between the plates, here the electric field is E, right? Then the force acting on any one plate, let's say call this plate 1 and plate 2, then we have to prove that force on plate 1 due to plate 2 is 1 by 2 QE, where Q is obviously the charge stored and E is this electric field. Is the question clear? Is the question clear, everyone? This is what we have to prove, right? Okay. So now, do you understand that this electric field, this electric field here, E, is actually the total electric field of both the plates or due to both the plates, correct? Right? Yes or no? And also both of these plates, they are going to create electric field of equal magnitude. See, I'm not putting vectors. I'm only writing magnitude because I know that both fields are in same direction. Derivation yaad chhe ne badane? Right? Okay. Is this clear? Yes or no? I'm waiting for you. Have you understood this line? Okay. No. Fine. Do you remember due to one large sheet, the electric field is actually sigma by 2 epsilon 0, right? In magnitude, it is always sigma by 2 epsilon 0, right? So that's why E1 and E2 both are going to be equal in magnitude. Okay. So over here, you have double electric field, right? So actually this electric field is going to be sigma by epsilon 0, right? So what I'm saying is total electric field is E, which is sigma by epsilon 0, but individual electric field is sigma by 2 epsilon 0. Okay. So now keep that in mind and now think about it. Who's going to apply force on plate 1? Who's going to apply force on plate 1? Obviously plate 2, right? Itself cannot apply force on itself, right? Okay, plate 1, it cannot apply force on itself, right? So force on plate 1 due to plate 2 is Q into E2. Yes or no? Right? Charge into electric field. Easy as that. Okay. But what is E2? થઈ ગયું ને પૂરું. Okay, that's it. પતી ગયો. અરે સીધી રીતે સાવ જ easy છે. Two plates both have equal share. તો એકનું electric field તો E by 2 જ આવશે. And this plate will apply force on that. So that force will be QE by 2. Simple. જો કહેવા માટે આ એડિશનલ નો ક્વેશ્ચન છે પણ શું કરવાનું હતું કંઈ નહોતું કરવાનું, રાઈટ? આવડી ગયું ને? So that's it, right? આટલું લખી નાખવાનું. શું લખવાનું? This. Okay, right? And then jump to this line. પૂરું. Now the question also says explain why you are getting 1 by 2. Explain why you are getting 1 by 2. ये समझाई છે? It's because why are we getting 1 by 2? Can you tell me that? Why are we getting 1 by 2? I'm waiting for your answer, everyone. Why are we getting 1 by 2? Okay. All right. Hmm. Yes. Yes. The reason is again very simple, right? It's that both plates create equal electric field, right? Both plates create equal electric field, right? So one plate only creates half, and that one plate applies force on the other, right? One plate cannot apply force on itself, right? So on plate one, only plate two will apply force, right? That's why it's half. It's not QE. See, it's not QE. તમે આમ બહુ ઉતાવળમાં કરવા જાઓ charge Q, electric field E. તો answer આવી ગયો QE. But that's wrong because this electric field is due to both the plates. For one plate or due to one plate only, it's half, right? That's it. Okay. So that's it. Fine. So this is QE by 2. ચલો હવે હવે આરામ કરવાનો છે. ડાઉટ્સ પૂછો, ડાઉટ્સ. ચલો 3 minutes છે. If you want to ask doubt, you can remain here. Okay. If you want to leave, no problem. Tata bye bye. Right. See you all tomorrow. If you leave, if you have a doubt, please stay connected and ask. We are not going to do anything ahead. All right. That's it. Okay. Aman, that is very tough question to answer. કોઈ પૂછતુંય નથી ને જતાય નથી. શું કરવાનું છે? નક્કી કરો હવે. કે હાય હેલો કરવાનું છે? બધા મજામાં છો એવું પૂછું? કોઈ પાછા છીક ન ખાતા અત્યારે આમાં. ભણવાનું કેવું ચાલે? બરાબર ચાલે છે? કે આ 2-3 કલાક ભણીને પછી એ પડી ગયા? હમ. તો ભણો ભણો રોજ પૂર્વેન્દ્ર. મહેનત કરો, એટલો બધો ટાઈમ મળ્યો છે. આમ મજા નથી આવતી. તારે શું કરવું જ જોઈએ? તારે ડોક્ટર બનવું ને તો પછી નીટ જ કરાય ને. શું કામ તું બોર્ડ એક્ઝામ નું ટેન્શન લે? આગ લગાડવા વાળું કોક હોવું જોઈએ એમ. કૃપા you could ask that directly, no problem. Okay. અહીંયા હું આન્સર નહીં આપું. ઘરે મજા નથી આવતી સ્કૂલ જેવી એમ. લે બોર્ડ થઈ જશે યાર. તું શું કામ ટેન્શન લે? તારે ડોક્ટર બનવું હોય તો બસ ફિક્સ જ છે. આપણે નીટ જ કરી રાખવાનું 24 કલાક. બોર્ડમાં કઈ ફેલ તો થઈ જવાના નથી. શું એવું શું વિચારવાનું? કઈ નો વાંધો આવે. ગોલ આપણો રાખવાનો અને કોઈ દિવસ એમ શું થાય એ મહેનત છોડી નહીં દેવાની, છેક સુધી કરવાની તો થઈ જાય. સ્કૂલ સારી હતી એવું લાગે છે તમને લોકોને હવે? આ બાકીના 36 માંથી 3-4 જણ જ કઈક કે છે, બાકીના તો ખાલી બેઠા જ છે. સાંભળો છો એમ ને? ચલો હવે ટાઈમ થઈ ગયો. હમ. ઘરે બધા હેરાન કરે એટલે એવું કઈ હોય. તો હવે ખબર પડી ને અમે તમને કેટલું રાખતા હતા. ઘરે તમને નથી રાખતા. હા ચૈત્ય ઓનલાઈન માં તો મને મજા નથી આવતી સાચું કહું. ચલો હવે ટાઈમ પતી ગયો, હવે નેક્સ્ટ લેક્ચર ચાલુ કરવાનું ને. ઓકે, વેરી ગુડ હર્ષ. So please prepare for things seriously. Entrance exams હોય, for railways you give that also. Okay, all right, goodbye everyone. It's already 2 minutes late, you have to start the next lecture.